Today here in IB, we're going to talk about how the derivative helps us with inflections and shapes. So we have a curve that looks like this. Its shape is said to be concave down. And if we have a curve whose shape looks like this, we say it's concave up. So what we mean in these cases is, let's see, in a concave down curve, if I were to go through and put in several of the gradients, and in each of these places, here the slope is 2. Here the slope is 1. Slope is 0. The gradient is -1. The gradient is -2. Notice as x increases, the gradient decreases. And that's also the first derivative. Which means that the second derivative has to be less than 0. Now a similar thing can be said about when it's concave upward, that the gradients are going to increase, and then that would indicate that the first derivative is increasing, so the second derivative has to be greater than 0. These places where we change shape called points of inflection. We have two types. This is just a regular point of inflection. And here we have a stationary point of inflection. Notice on the stationary point of inflection that the first derivative at that value is equal to 0. And over here, the first derivative at that value does not equal 0. In this case, the first derivative is negative because my function is decreasing. So for us to find points of inflection. So point A is a point of inflection if the second derivative at A is equal to 0 and the sine of f of A changes on either side of x equals A. Our textbook has several examples. Examples 13 through 16. We'll show you how you can find the points of inflection. I'm going to try a couple here. If the pen still keeps acting up, I'm just going to leave those examples for you. So the first one I want to try, wish me luck, is to classify, let's see, I'm going to do 2e. We have f of x equals 3x to the fourth plus 4x cubed minus 2. And the instructions in E have us do 5 things. Find and classify where the first derivative equals 0, classify all points of inflection, find where the function is increasing and where it's decreasing, the intervals where it's concave up and concave down, and use that to sketch a graph of our function. So let's first find our first derivative. That would be 12x cubed minus 12x squared. The second derivative would be equal to 36x squared minus 24x. Now we set our first derivative equal to 0. We can factor out a common 12x squared. It's going to give us x minus 1. So our values here to examine are x equals 0 and x equals 1. Over here, if we set it equal to 0, factor out a 12x, we're going to be left with 3x minus 2. And that's going to give us x equals 0. Something's happening there. And x equals 2/3. This was x equals 0. X equals 1. So for each of these, let's do a sign chart. So here, at 0, we add 0. At 1, we add 0. Now we take a number larger than 1 and plug it in. We're going to get positive. A number between 0 and 1, like a half, this part here is going to be negative, so we'll have a negative. And a number smaller than 1, both pieces are going to have a positive times a negative. And so we're going to have a negative. That would be the sign chart for there. So we can see at x equals 1, we have a local min because we change from negative to positive. Over on our second derivative, at 0, our second derivative is equal to 0. And at 2/3, our second derivative is equal to 0. A positive value, a number bigger than 2/3, like 1, would make 12 times 1, which would be positive. A number between 0 and 2/3, like a half, would be 1½ minus 2, which is negative, times 6. So a negative times a positive is a negative. And a number smaller than 1, 0, excuse me, like negative 2, would make negative times negative, and that would be a positive. So to answering the different parts, and let's see, our key points were 0, 1, and 2. So we have 0, 2/3, and 1. We put those back into our original function. When we put in 0, we get negative 2. When we put in 1, we get 5. Then the tricky one, when we put in 2/3, we have 16/9, 32 over, let me change that to 16/27. Plus 32 over 27 minus 2. So that's 48 over 27 minus 54 over 27 would be a negative 6 over 27 to be a negative 2/9. So these are the actual points that we have. And so we said at 1, we have a local max. So the point 1, 5, it's a local max, min, excuse me. Point 0, negative 2. It was neither a min or a max because the sign didn't change at 0. But over on our second derivative, the sign changed from positive to negative, so it is a point of inflection. And since our first derivative was equal to 0, it's actually a stationary point of inflection. and then the point 2/3 to -2/9. It's changing sign from negative to positive, so it's just a point of inflection. And it's not stationary because at 2/3 the first derivative doesn't equal 0. Now where is it increasing, where is it decreasing? It's increasing when f prime is bigger than 0. So we look at that. That is from 1 to infinity. And it's decreasing wherever we are negative for our first derivative. And that would be from negative infinity to 0, and then from 0 to 1. We can't just say negative infinity to 1 because at 0 it's not increasing or decreasing. Concave up. Our second derivative has to be greater than 0. Second derivative is greater than 0 up to 0 and after 2/3. So from negative infinity to 0 and from 2/3 to infinity. It's going to be concave down at all other places. So that would be from 0 to 2/3. Our graph. We need 2/3. We need 1. So in our graph, taking all of our information, we have to be increasing, from negative infinity to 0, we're decreasing. Then we keep decreasing, then we increase. At 0, we have a stationary point of inflection. Then at 1, we have a minimum. And that minimum value is, I believe it was -5. It was 5. Okay, and we have a problem. Because here, at 0, I'm at -2. At 1, I'm at 5. How can 5 be a minimum? Let's see. So I have 7 minus 2 is 5. At 0, I have -2. That's always positive. I don't see my error. Tell you what, find my error, finish the graph, show it to me tomorrow, for extra credit. You must work individually. And I do have a few questions for you. Number one, some advice. Take your time and be careful. So we're in 21F. We're doing 2D, F and H, and 1C and E. And that should be plenty for us. We'll talk about how to relate graphs when I'm back.